Awesome.
Okay.
Perfect.
And thank you so much, Maria, to invite me for this Lipid Spring School. And hello, everyone. I'm Hiroshi Tsugawa of Tokyo University of Agriculture and Technology. I was actually the researcher of RIKEN until last month, but I actually left RIKEN Research Institute last month and I started my new career at this university as a PI. This is just a quick update from me. Okay. Okay, today I will do a tutorial of this MSIR program as a developer, and I will do the general introduction for around 10 minutes by using these PowerPoint slides, and then I will do a demonstration of this MSIR program, especially for the beginner of Liptomics. I actually started the development of MS-Style program at 2014, and the first version was released on 2015. And this software is a kind of all-in-one software program for untargeted metabolomics and lipidomics, basically based on GCMS and LCMS and ion mobility instrument. And in near future, direct infusion MS data will be also accepted, and nowadays the monthly download exceeds 6,000, and I improving this program by many feedbacks or suggestions from the Metabolomics Society forum. I just show you the Society forum web page for your information. After you register, so you can put your comments, suggestions, and feedbacks, for example, for MS-Dial program here. And I would like to emphasize that so your feedbacks are very welcome to improve this MS-Dial environment. And this is the overview of MS-Dial, and this program accepts the common data format like NetCDF or MZML, and you can convert your MS raw data by using the converter program. And recently, this MS-Dial program supports the direct import of this red color vendors format without any data for conversion. And this software program supports any type of MS data like this, so it's like this MS, LCMS, or data independent acquisition, or LC ion mobility MS, or LC ion mobility DIMS, something like this. And I will give a quick tutorial today of LC MSMS lipidomics data processing. In lipidomics, so MS-Dial uses the in silico MSMS spectrum library for lipid annotation. The basic concept of this strategy is the mass fragmentation pattern will be very similar in each lipid subclasses. In this phosphorylcholine case, so the mass fragmentation will be started around these SL bonds, even though the acyl chain lengths or double bond number are changed. So therefore, we can predict the MSMS lipid MSMS spectrum pattern, and we can prepare the MSMS spectrum libraries computationally. And I recently created the tandem mass spectra of more than 120 lipid subclasses, and at these panels, the black color spectrum is the experimental spectrum of displayed lipid structure, and the red color MSMS spectrum means in silico spectrum. And we published this spectrum database as Lipid Tandem Mass Spectral Atlas 2020, and you can download these spectrum libraries as MSP format from my website, and these MSP spectrum format can be used in other software programs instead of MS-Dial. So in addition to making the spectrum libraries, so I created the source code to appropriately describe the lipid structure information based on the quality of MSMS spectrum. Okay. Okay. This is an example of MSMS spectrum of sphingomyelin as acetate adductome in negative ion mode. And here we can actually see the sphingomyelin specific product ion or neutral losses. And we can also see the acyl chain specific ion, also the abundance is very small in our experimental condition. But for the annotation, this MS dial program uses a hybrid scoring system. One is the classical spectrum similarity matching using dot product or reverse dot product scores. And actually this scoring is very useful to filter out noisy spectra. And also this program utilizes the decision tree rule-based algorithms for lipid or for each lipid subclass. For example, in this case, this program will check the existence of sphingomyelin specific product ion or neutral loss in the MSMS spectrum. And after this, this program will check the existence of fatty acyl chain specific ion to define the acyl chain compositions. And the final description is determined based on the existence of these characteristic ions. And I wrote this decision tree program for all of the lipid subclasses that MS-DIAL supports. Then, actually, the important things in untargeted lipidomics is to describe lipid structures appropriately by considering the MS resolutions. The MS-DIAL nomenclature system follows the criteria of Lipidomics Standard Initiative and lipid maps, and you can learn the MS-DIAL lipid nomenclature system by going to my MS-DIAL webpage, or you can learn this in the recently published article by Gerhard Ribech. And I also provided the retention time and collision cross-section values of lipids. And previously, I performed the machine learning research to predict retention times, and at least for our HC condition, lipid chromatography condition, and to predict the collision cross-section values obtained by, in this case, Burkhardt stuff. Therefore, so if you follow our LC condition, so you can use the retention time information as well for your annotation pipeline. And you can also use the CCS information if you have ion mobility instrument. Then almost last. So for your information, so many programs support MS-DIAL environment. So for example, so if you start the metabolomics research instead of lipidomics, you will see many unknown peaks. And in such case, you can use MS Finder program to predict molecular formula and structure of unknown MSMS spectrum. In addition, for example, you can use GNPS environment for the annotation purpose of unknown metabolites. For further details, so please go to each program webpage. And I just want to say here, so these software programs should be very helpful for lipidomics as well. Okay, so this is a quick summary of MS-DIAL environment. So this CompMass means computational mass spectrometry, which is my major in my research career that aimed at converting from MS to structure to understand the metabolisms. And so MS-DIAL supports, for example, in the lipidomics area in silico MSMS spectrum annotation pipeline. And from now, so I can demonstrate this MS-DIAL software program by the demonstration data. I actually prepared the demonstration data set for this lipid mass spring score. And this raw data was obtained in this research recently published in Nature Biotechnologies. And here, so you can, if you download this Lipid Map Spring School demonstration kit, you can see, for example, MS Dial latest version and the raw data set, so which contain the positive and negative ion model data of liver extract samples, lipid extraction samples, and also I prepared the parameter files so that were optimized for analyzing this liver sample. And for example, this text file contains a library for annotating the standard compounds of splash lipidomics. Okay, I, oh, yes, I will. Maria, can you see this screen as well?
Yes, I see
Okay.
now the blue screen and the folder opened.
Okay, thank you so much. So I actually downloaded the lipidomics Spring School demonstration kit here, and let me just show. So you can, for example, type, you can write at this moment, and here there is my web page, computational mass spectrometry, and so you can go to MS Dial web page here, and sorry, so there is a demonstration file section, and here you can see the Lipid Map Spring School demonstration file kit. Then I just click here and I downloaded this. And you will be able to download this demonstration kit. And from now, I just open MS Dial exit file like this. Then actually this folder contains the raw data, so from SciEx instrument. Then just click File, New Project, and you have to choose the folder contains the raw data here. Then, so because this data was obtained by LCDDA method, so I just use the default set until here, and I use the profile mode because this big file contains the profile mode data, and because this negative ion mode folder contains negative ion mode data, so I choose this. Then, because this is a lipidomics data, I choose this lipidomics function. Then I click here. Then I just click browse. Then I select the WIF file format file, and you will be able to see the WIF files here. Then I just select all of the files. Then in this folder, I actually prepared this Excel file. So I just copy, Control C, and paste here something like this. Then, so I just prepare the metadata file set. So because this file is blank and the other file are some biological samples, and I just set the class ID like this. Then after this, so I copy this and I actually paste this information into this data grid by Control V. Then I click next. Then, so I'm sorry, there are several parameters. like this. So to reduce the explanation time, in this time, I prepared the parameter file here. And if you import this parameter file, the optimal parameter was automatically set. Then I just want to say here, in the identification tab, if you click this select button, you will see this option. So you can check the lipid subclass that you want to annotate here. And I actually always click check all, then I click finish to increase the coverage of limits. Then, so practically, I prepare this text library. So I just show you. So MS Dial supports this kind of text library for the annotation purpose as well. The must column is the compound name and MOBAGI values, and others are option. And actually, I always prepare the compound name, MOBAGI, and the retention time for annotation. And I actually use this text library for annotating the internal standards like this. Then, so I select this text library, and then I just click finish, and the processing is started. And meanwhile, so I'm always open another MS-Dial program, and I set I will start the processing for positive ion mode data like this. Project. Then positive ion mode and lipidomics, and browse, then with file, and then choose this, and I paste the same parameter set. Then I load this positive ion mode parameter file. Then, so for the annotation of the standard compounds, I import these text libraries. Then I simply click finish. And this MS-Dial program supports this kind of multi-thread processing to increase to do the rapid data analysis, something like this. So meanwhile, so because maybe the analysis will be finished very soon, but to reduce the explanation time, I've already finished analyzing the data here. So the negative done and positive done. And I will open this already finished project like this, and file open project, and I also open the positive IO mode data. Then basically, so practically I will double click this alignment result file, and then, so for example, in the main window, you can check the MSMS spectrum pattern of experimental spectrum and the in silico MSMS spectrum pattern and the abundance in the metabolic profile information on the Volvo panel. And you can also check the chromatographic milligram patterns, something like this. And practically, I always click this show ion table to check the summary of this lipidomics result. And I click this reference matched button to show the only annotated peaks by the MSMS spectrum libraries. Then, so for example, I always check the peak shape by the standard compounds data like this. So, and if you find, okay, this peak recognition is wrong, you can quickly change the peak area like this, or you can do this kind of the peak curation by this way, something like this. And for example, after I finish the checking the annotation result and the peak quantification result, I always do so data normalization by splash lipidomics option. And because I used the splash lipidomics first version in this project, I click this. And so because, so I will skip this explanation because it's a bit difficult to explain this by this short time, but I quickly explain. So as an internal standard, so these internal standards were contained the LCMS buyer by this concentration. Oh, I'm sorry, this micromole. Then as, so after the concentration of internal standard is calculated by picomole per milligram tissue unit. So the final concentration becomes something like this. Then, so because I would like to export the final concentration result by this unit, so picomole per milligram tissue at this moment. So in this case, I have to multiply this value by 2 times, and something like this, and oops. Then so I'm sorry, I just data normalization. Then splash lipidomics and picomole per milligram tissues. Yes. Then if I click this find button, so the automatically this program will check the alignment ID of each peak spot. And after I set the standard compound name and the target lipid class for lipid normalization, and I click finish, then so the Y value will be changed from the peak height value to picomole per milligram tissue, something like this. Then after this, for example, so I will do the same things in positive ion mode. Then I click finish. Then yes, picomole per milligram tissue. Then, for example, as a data visualization, so you can do the principal component analysis and you can check the loading value, something like this, or you can do the hierarchical clustering analysis like this way, and so you can check the compound name as well in this window. And also this program supports the pathway analysis. And for example, I would like to combine the positive and negative ion mode data. And because, so this data is coming from negative ion mode, I will combine the positive ion mode data into this project. Great. Yes. Then I just click this mapping button. Then you can check the lipid abundance information. So for example, if I click this, so this PI means, oh, so you can check the PI molecular profiles for the total ion chromatogram and each molecule result as shown here. Then also if, for example, you want to use some meta-analysis or R software program to do further statistical analysis, so you can export this alignment result by this way. So I just click desktop. Then I just click raw data matrix and normalized data matrix, and I click export. Weird. And in the desktop, so two data files will be exported, and this height text file contains the peak height quantification result, and this normalized file contains the normalized result by the splash lipid mixture. Then, for example, I just drag and drop this file into the Excel file, and you can check the result by this way. So you can see the alignment ID and the retention time and the M over G values, and for example, metabolite names and the adductor type and molecular formula, lipid class ontology, and the representative NGTL SMILES code, and MS1 spectrum pattern and MS2 spectrum patterns, and each cell contains the peak abundance information for brand or biological samples, and you can see the average or standard deviation value in this Excel format file. Okay, maybe I should keep 7 or 10 minutes for the questions. And so I would like to finish my tutorial sections, or if you would like to know more for further detail of MS Dial program, I very welcome your question or comments.